In this lab, we will continue with unsupervised learning visualization. So we will use mixture-based clustering to visualize the data. We'll use the variance subfamily of multivariate normal mixtures. We'll find the clustering results with two clusters and show the results in a pairwise plot. So model fit for varying variance subfamily. Let R equal M clushed of the reordered dataset with the majority class fetched. G equal 2. So we are forming two clusters. Model names equal varying VVV, and we have clushed model object VVV, two clusters are formed. Available components call data model name N D G BIC log likelihood degrees of freedom BIC ICL HYP VOL parameters Z classification uncertainty. Summary of R is a Gaussian finite mixture model fitted by EM algorithm, clushed VVV of ellipsoidal varying volume, shape and orientation. Model with two components. Log likelihood is minus 5870.467, N is 1000, degrees of freedom is 41, BIC is minus 12,024.15, ICL is minus 12,044.85. Clustering table. One is for nasal group, nasal class, index 329 of them, and 2 is for oral class, and there are 671 of them. Plot mixture based clustering. So plot R, uncertainty. Title main equal uncertainty for two centers. So we see that so for the uncertainty graph, we look at these are the second ones. These are the centers over here, and then the dots represent the data. The large filled circles show high uncertainty that the observation belongs to that class, and the small filled circles show low certainty that the observation belongs to that class. So the nearest to the center of the clusters, the data which are nearest has bigger circles, and further away the circles are smaller. Then we plot R and the classification part of it. Title main equal classification for two centers. So we see that these are the data, the two clusters that are printed. So for y-axis equal v1 and the x-axis equal v2, the data is represented like this. And the rows represent the labeling on the y-axis, and the columns, they represent the labeling on the x-axis. The larger filled circles show Okay, this is for the uncertainty. In the following code, we show the results in a pairwise plot of the data using different colors and points type for observations of different clusters with the majority class fetched. Pairwise plot of the data using different colors and point types for observations of different clusters. Pairs of the reordered data frame with the majority class fetched, comma, color equal continuous 2, 4, and then square bracket R at classification, comma, PCH, this is the size of the symbols, equal continuous 1, 3, and square bracket R at classification, comma, main equal G equal 2 with the majority class fetched. And we get this. The pairwise plot of two clusters by mixture-based clustering method shows that the observations are divided into two groups of clusters. Also compute the adjusted rand indices for k equal 2, 3, 4, 5, 6, 7, 8, 9 clusters. Compute the adjusted rand indices for k equal 2 to 9 clusters. Let array equal 8. So there is an array of 8 zeros. For k in 2 to 9 curly braces, R1 equal make cluster of found me, removing this last column, which is the class column, G equal k, model names equal VVV, and array, which is the array, the place value k minus 1 equal adjusted rand index of s dot integer of found me at class, comma, R1 at classification. So this is the similarity measurement. And printing array, we get this. So we can see that the lowest among this is 0.02963741, and this is forming 2 centers. And the highest of this is 0.07091669, and this is forming 4 centers. From the results, all the adjusted rand index values are very close to 0, showing that there is a random allocation of observations into each partition. The highest similarity is from forming 4 clusters. The lowest similarity is from forming 2 clusters. Then we will show for 2 clusters and 4 clusters for one of the examples using V1 and V2. Let pass the command set.seed12345 because the k-means function is random. Then 2 clusters with k-means method, let's form that. Let R1 equal k-means of this reordered data frame, and excluding the last class column, comma, centers equal to. Pairwise plot of the data using different colors and point types for observations of different clusters with bracket RB, comma, plot V1, comma, V2, comma, color equal continuous 2, 4, a square bracket R1 at cluster, comma, main equal k equal to data with majority class fetched, points R1 at centers, comma, color equal continuous 2, 4, comma, PCH equal 19, comma, CAEX equal 2, and we get this. Comment: the pairwise plot of 2 clusters by k-means method shows that the observations are divided into 2 groups of clusters. The largest circles show the cluster centers. Now we will plot the 4 centers. So pass the command set.seed12345, and then we will form 4 clusters with k-means method. Let R1 equal k-means of RB bracket -6 is getting rid of the last class column, centers equal 4. Pairwise plot of the data using different colors and point types for observations of different clusters with RB, plot V1, V2, color equal continuous 2, 3, 4, 5, square bracket R1 at cluster, main equal K equal 4, data with majority class cluster fetched, points R1 at centers, color equal continuous 2, 3, 4, 5, PCH equal 19 and CEX equal 2, and we get this. We get the 4 clusters. The pairwise plot of 4 clusters by K-means method shows that the observations are divided into 4 groups of clusters. The larger circles show the cluster center. We used varying variance subfamily of multivariate normal mixtures to find mixture-based clustering results and showed the results in a pairwise plot. We also computed the adjusted range indices to examine the performance of an unsupervised learning method for a supervised learning method.